Welcome to Lesson 17. In this lesson, we are going to explore a new feature, move on from Loft that we've been looking at for the last few lessons. So this lesson 17 and the next one 18, we will look at the Coil command that is right up here. Here's a very basic spring type coil shape. We'll look at a couple of these examples where we create this solid as a coil all by itself in this lesson, and then in lesson 18 we will use coil again, but use it with some existing solid geometry that's already there, both to create new material on that, adding a thread to a screw, and then we will cut with it as well. But let's look at these two examples first. Let's start a new part. Standard IPT. We will start a 2D sketch on the XY plane, and to create a coil we need two things in our sketch. We need the profile that we are going to coil around an axis. Let's draw that circle right there for the moment, and then we need the axis itself. So let's draw a line from the origin. We'll take that straight down. Let's make it 4 inches. We're not necessarily going to use that 4-inch number, but I like to have it just stuck down and defined and fully constrained so that it doesn't get away from us in any way. Now, since this is the center line of this coil, let's make it a center line. And since we are not using it directly to create geometry, let's make it construction geometry. So it gets lighter. We see the dash pattern there indicating it is a center line. Now let's work on this circle. Let's put a horizontal constraint off the origin to the center of this circle. Let's give it a dimension off the center line. See, it comes up as a diameter. It goes all the way across. Let's give this a 1-inch diameter, and then we will define the diameter of the circle itself as 0.090, 90 thousandths. If this is a spring, that is the diameter of the wire that makes up this spring. Say OK and finish this sketch. So we have our closed profile that will become the wire. We have the center line around which we will rotate. That is the two things that are required for us to use coil. So click on the coil command up here. Notice since I only have those two things, I have one closed profile and I have one line that can be used as an axis that was defined as a center line. It automatically picks those for us. As we move down through this box, we have a couple of different ways that we can define the way this spring is formed. We have a drop down here that says pitch and revolution, revolution and height, pitch and height, or spiral. Let's look at pitch and revolution first. The pitch is the distance wire to wire. See, let's look out here at the edge from here to here. That is the pitch, which is currently set at 1/2 inch. If we make that half of that value a 1/4 inch, see, now it gets shorter. We have 2 rounds of that coil where previously we had just 1. If I take it from a 1/4 inch and make it 1/8 of an inch, they get tighter. While we're looking at fractions here, let me show you one thing real quick that Inventor can do. I know that 0.5 is 1/2 inch. I can also work in fractions, enter 1 divided by 2, 1 over 2, and there is my 1/2 inch, and it shows me in that little pop-up there that that pitch is 1/2 inch. I can make it 1/8 inch, and it shows me that it is 0.125. Inventor will help you out by doing the math for you. But let's take this back to 0.5, or 1/2 inch, and move on to the next box, which is the number of revolutions, because I am defining this by pitch and revolutions. Let's give it 10 revolutions. I don't want to taper this one right now. Let's just leave this one the way it is. There we have a very simple spring, 90 thousandths diameter wire, 10 revolutions, 1/2 inch apart. But let's go back and edit. We can dig in a little bit more to what some of these other features are. Instead of pitch and revolution, let's go with revolution and height. See, here I have 10 revolutions. I'm defining the number of revolutions that I want, And then I can tell it how tall I actually want this spring to be. If you were designing something where you knew the number of loops your spring needs to make, and you know a height that it needs to fit in, when it is compressed, you can show the compressed state, you could show the extended state. Let's make this one 1.5. See, that stretches it out a little bit. See how close those coils are to each other. Go back in and change the number. Let's say we want this whole thing to be 2 inches. Now we are spread out a little bit more. Do it again. I want a height of 3 inches, and it continues to spread it out and adjust the pitch between each coil as we change that height. Let's leave this one for now. Let's save this as lesson, 17A, and save. Let's do another example, and we'll dig into a few more features as we do that. Create a new file, another standard, start a new sketch on our XY plane. Let's go back and draw a center line as we did before. Call it a center line, call it construction geometry. And springs don't always have to be round wire. Let's make this one with a little rectangle. Let's put the inside diameter, hit that edge. Let's make that 0.750. Then we will define the width of this wire. Make that 125. As I could also do 1/8, eighth of an inch, 125. Let's make this height, let's say that was 330 seconds, which is 94 thousandths. Let's add now see what happened here. I had selected that line. I was on a line, and I hit the horizontal constraint, and it gave me an error that sketch constraint already exists. I want to be sure I don't have any geometry selected. Now I can use the horizontal constraint to come over here to the origin and to a corner of my rectangle. And that sticks the origin and the corner horizontal to each other, gets that rectangle locked up here at the top. It tells me I still have 1 dimension needed if I want this sketch fully constrained, which is the height of that center line. It doesn't necessarily matter, but like I said, I like to have it fully constrained, everything stuck in place. Let's finish this sketch. We'll go up here and create coil again. Let's go with revolution and height. That works for us. 15 revolutions and a height of 2.5 inches. I don't know. Okay. Let's take a look at this spring. When I square up to the side here, I can see how the top of this spring comes up at an angle to its endpoint and stops right there. If this spring needed to fit, say, in a counterbore hole, needs to fit between 2 flat surfaces, that surface isn't going to rest well on the part that it mates with. So let's edit this part. We have the option here at the end to close the start and close the end. Let's leave those angles as they come up right now. Let's give it the same treatment at the end. We will put in 90 and 90. Say OK and see what that got us. See, it flattened out that end, so it will sit flat in a pocket or flat on a surface rather than having that point sticking up. Now, let's take a look at the behavior of this coil and these ends. Let's get rid of that bottom one for right now. We're just going to look at the top. Notice the 2 things that we have here. We have a flat angle of 90 degrees and we have a transition angle of 90 degrees. That is, if we see this area, say 90 degrees of this. Let's look straight on at the end. So 90 degrees of it from here around to here, that's going to be flat, completely flat. If I go and look across the edge, there I have that much of it that is perfectly flat. If I rotate and look at this side, you can see this part over here that is still completely flat. And then through this section here is where we have the transition, that it goes from the slope of the coil that it forms as it makes its loops. So between about right here and up to right here, that is where it transitions from the curvature that is formed by the spring into the flat section. So we can go back in and change those. Let's make this transition angle, let's shorten it. Let's make that 30. Make our flat angle 180. So that will be half of this circle then that is completely flat. And then part of it, 30 here, that is our transition. Now let's look at what happened right here. This spring sort of crashed into itself. The inputs that we gave it, the 30 degrees of transition and then the 180 degrees of flat, causes it to crash into itself. So then we need to come back in. Maybe if I just do 150 degrees. Nope, see, we still got a little bit of intersection there. Make it 120 there. At 120 degrees, it does not intersect with itself. Let's go back to our coil parameters one more time. We won't take the time to go through and go into detail on each one of these, but so far we have used these two. We've used pitch and revolution. We've used revolution and height. Go in and mess around with these. Use pitch and height. Play with those numbers there. See what different results you get. We have not used taper. Put that back on revolution and height. Look at taper. You can add a taper to this spring. Coil it in and out. Positive number goes out. -5 degrees. That tapers to the inside. Come up here and try spiral. Spiral lays it out flat. So come in, play with those numbers. You're not going to break anything. Try different options. If you get an error message, see what it says, see how you can fix it. Just work with it. Go through the different options. Practice it, learn, and then come back for lesson 18. We will use coil again, as we said, to put some threads on some screws and bolts. We'll see you then.